Hi everyone, this is Sahil from QuickNode, and in this video, we will learn to create an AI agents trading platform on the Fuel blockchain. And the interesting part is that the platform will have multiple agents, each with their own trading personalities. So without any ado, let's jump into it. So before going into the app, let's first understand what is Fuel. Fuel is a modular execution layer built for Ethereum. It's a very high performance layer which supports parallelization and has high throughput and very low transaction costs. So there are few things that makes Fuel very unique. And those are first, obviously, the parallel execution feature, where traditional blockchains execute transactions one by one. Fuel can execute transactions simultaneously. And this is achieved by incorporating a UTXO model, very similar to Bitcoin. UTXO model is an unspent transaction output model using which it can achieve parallelization. Fuel also comes with a new virtual machine called Fuel VM, and they have developed their own smart contract language called Sway, which is based on top of Rust and Solidity, which gives you high performance and efficient smart contracts that can interact with machine level component very efficiently, thus making the entire process and operations very fast. And then the most important one, it's Ethereum compatible, which means that all of your Ethereum applications or applications deployed on any Ethereum rollups or layer 2s can be deployed on Fuel as well. Now let's see that what we will actually build today. So we are going to build this AI agents platform today, which is not just any other platform. You will get access to multiple AI agents personalities, or I should say traders personalities, like FOMOer, who is an emotional trader who buys pumps and panic sells dips. Degen, who maximizes risks and is always going for those 100x yields. Diamond Hands, who always accumulates and never sells. And Whale Watcher, who follows smart money moves. Now let's understand the architecture of our application. So on a very high level, our application will have three layers: the front end layer, AI and logic layer, and the blockchain layer. The front end layer will consist of React plus TypeScript. We will be using the White.js React framework and TypeScript to create our application. It will consist of our trading dashboard, wallet integration, state management, everything. Then the core of our application, the AI and logic layer, which will have those 4 AI agent personalities ran by OpenAI integration. It will do market analysis, will do risk management, and everything will happen on the Fuel blockchain, where the blockchain layer comes into the play. The blockchain layer will interact with the Fuel blockchain, do swaps or buy token, sell token using the Mira Dex TypeScript SDK and the Fuel SDK, and it will also do asset management. So our app right now will only support 3 tokens: ETH, Fuel, and USDC. And the data flow or the user journey of the app will look something like this, where a user would connect their wallet, they will select a AI agent personality, they'll see the real-time market data, they'll chat with the AI agents, analyze the trades suggested by the agent, and then execute the trade. The app will use 4 major tools. First one is QuickNode's CoinGecko API from the QuickNode marketplace, which will get us real-time ETH, Fuel, and USDC prices. We will use the OpenAI API to get access to OpenAI's GPT 3.5 model. We will use the Mira AMM. Mira is a DEX and has AMMs on Fuel network. We will get access to Mira AMM via their TypeScript SDK and the Fuel network, because everything will be happening on the Fuel network. So for the purpose of this demo, we will be using the public endpoints from Fuel because we will be connecting with their wallet, and right now it's kind of difficult to add a custom URL to the Fuel wallet via program or programmatically. So we will just use those URLs, but you can add your custom or dedicated QuickNode Fuel URLs to the wallets to make the transactions faster and to avoid any rate limits. Now let's understand our code base for our application. The entire code base will be linked in the description below as a GitHub repository. You will just have to clone the repository and do npm install. So we will understand the code base in these following steps, where the first step will be to understand the project structure and understanding core configuration files. So our project structure would look something like this, where we will have the source directory, we will have the public directory, but in the public directory we just have the favicon for fuel. This is a mock fuel icon, not the actual fuel icon. And in the source directory, we will have all the agent logic in the agent directory. We will understand all of the files one by one, but let's first understand the structure. Then we will have components, which will hold the React components, the configuration files, which will hold the entire app's configuration and constant, contexts, which will hold React context for global state, custom React hooks in hooks, a OpenAI library file so that we can interact with OpenAI API, external API integrations in services, and our TypeScript type definitions in types. Then comes few UI handlers and our main file, which will be the main entry point of our application. So in the environment variable file, we will have the OpenAI key as well as the QuickNode CoinGecko URL. So QuickNode CoinGecko URL is nothing but a API URL using which you can interact with the CoinGecko API to get the live prices of assets or tokens. So to get started with this, you basically just have to come to this page, and this will be linked in the description below, and click on get started. And once you click on get started, it will take you to your QuickNode dashboard from where you can install it. Since this is already installed on my account, it's showing up like this, but for you, you will have a install button over here where it says change for 4 endpoints. Let's understand the config file, which will hold all the constants, environment variable validation, and the network switching between mainnet and testnet for wallet validation. Then it will also hold the token constants for all the tokens which we are supporting. In this case, ETH, Fuel, and USDC. We will have their addresses and asset IDs specific to Fuel blockchain on testnet as well as on mainnet. Then in types, we will have the central type definition for our entire app. This will make sure how TypeScript ensures type safety across the components of applications. Then it also has key interfaces that defines our data structures for our application. Then comes the external services and data layer. In that, let's understand the services files. The first one will be real market data service, in which we will get the real data from blockchain, where first we are getting the price of tokens from the QuickNode API by using this custom method, which gets enabled once you have the CoinGecko add-on installed on your endpoint. The custom method's name is CG_simple_price. Then we are basically just processing those and getting the prices or 24-hour high, 24-hour low. But for that, we will have to keep the app running. But for our demo purposes, we will still have those 24 hours high, low, but for the limited period of time since the app is running. Then we are calculating some technical indicators like RSI and volume. For volume, we are just hard coding the volume right now for the demo purpose, but for your use case, if you want to deploy such applications in production, you can get the volume from another QuickNode Marketplace APIs like Coinmetrics API or CoinPrice APIs. So going back to our code, so this is what we are basically doing in this file. And then in the whale tracker service, what we are basically doing is we basically have few mock whale transaction data, and we will show them in the dashboard itself, using which our agents can make decisions in the whale transaction monitor agent. But again, in production, you can get the transaction data from live blockchain, parse them, save them in a database, and feed that to your agent via this file, so that your agent can have context of some whale transactions. Then in the notification service, we are basically handling the notifications or in-app notifications of successful transactions, unsuccessful transactions, what error we get, we show them on screen via a notification badge. And then we are basically just doing a barrel export of all of those files. Now let's understand the AI agents architecture. So our agents logics, or all the agents logics, are stored under the agents directory, where first we will have the FOMOer agent, where we are telling the API or the OpenAI API that this agent is an emotional trader who experiences FOMO, fear of missing out easily. You panic sell when price drops and rush to buy when price pumps. You make quick decisions, impulsive decisions on market momentum. You're always worried about missing the next pump. So we are also giving it few traits over here. As a FOMOer, you do this, and the same goes for Degen agent, where we are telling it that you are a Degen, you are always hunting for 10x or 100x opportunities, and then giving it few traits over here, or few commands that it needs to take care of. Same goes for diamond hands over here. We are telling it that you are a long-term investor, you believe in long-term gains, every dip is a buying opportunity for you. And then same goes for whale watcher, you believe in successful trades or successful traders and follow institutional players, etc. Then comes our base agent.ts file, which is our main file which handles all of these agents and their patterns of trading. So once you select the personality of the agent, we are giving the command to the base agent or the agent which is selected that you have conversations about crypto and trading and general topics, analyze market conditions when asked, and suggest trades when appropriate. So we are giving it few commands which says that you take the number of tokens which the user wants to buy or sell from the user, you give a trade suggestion, then while doing trade, get the amount in the context and create transactions. Then we also have some simulated responses for each personality of the agent, and based on that we also have some general chat responses for each agent. And the interaction with the OpenAI API is handled by OpenAI provider.ts over here, where we are creating a new OpenAI instance, and it will be using OpenAI API key which we have in the environment variable. Then comes the React hooks and state management, where under the hooks we first have the use agents.ts file, which initializes the agent, gets the market data from the APIs. Once the agent is selected, clear any previous subscriptions, subscribe to market updates for the selected token, whatever token we select, fetch the initial data, analyze the market, and give those metrics to the agent. Then we have the use notifications hook, which handles the notifications for our in-app notifications, which we saw earlier. Then the main file, useTrading.ts, is the file which handles the Fuel wallet connections, the trading decisions, as well as the trades execution. Where first thing we have the wallet connection or wallet integration using the Fuel SDK, then the execute trade function which executes the trade, where for each decision of the agent we have the following messages. Then we have few conditions where if no token config is provided by the agent, throw this error. If token config is asset ID is equal to base ID. Base ID is our ETH, as you can see over here, which is set in the config file over here, so that we can buy using ETH and sell any token and get output as ETH. Then we check balance for ETH for gas. Then we create a Mira AMM instance, prepare the swap parameters over here, then determine the asset IDs for buy, so set the in token as the base ID. Then we create a pool, and then we calculate the output amount. Then we execute the transaction over here, where we use the swap exact input method from the Mira AMM, and then send the transaction. And then we extract few transaction details and we print these details. And we also have some error handling over here, where if any error occurs, we catch it and print those errors. And then we have a barrel export file for all the hooks as well, We also had a similar barrel export file for all the agents as well. I didn't mention it earlier, but we have that for agents as well. Then come the context and global state, where in the context directory we have network context.tx, which helps us in global network state management and handles automatic network validation for testnet and mainnet, helps us with testnet and mainnet switching, and gives error if a wrong network is selected. For example, if you see our app is right now connected to Sepolia, our wallet is on Sepolia as well, but if we switch to mainnet, it will give us this error and give us some instructions around what we should be doing. And now comes our UI components architecture, where first we will see our main UI app will handle conditional rendering of the error message based on the type of network, the logic of which will come from network context file, which we saw earlier. And the error message was something like this, where it will show that if the network is wrong, it will show network is wrong along with the steps to get on the right network. Then we have our main app rendering over here, where we have the wallet connect button, we have some text, and once the wallet is connected, we have the agent selection flow after that. And once the agent selection flow is done, or once the agent is selected, we will be using few components, and from components we will be using the trading dashboard component, where it will have a grid layout of various components like the chart box, the volume box, the balance interface, etc. And all of those supporting components you can see over here: the agent metrics, agent selector, chart interface, market stats, trade confirm modal, trading chart, whale activity. And again, over here we are doing a barrel export. So the trading dashboard basically has all these supporting components integrated into one view. Then in the wallet component, we have the wallet connector component, which helps us to connect the wallet. In the wallet balance component, which helps us get the balances of the connected wallet and display them. So it fetches the real balances from the fuel wallet, it handles the decimals, shows the balance in a well formatted manner based on the decimals of the tokens, and it refreshes the balances every 30 seconds. And again, we have a barrel export for this as well. Then in the common components, we have a header component, a loading spinner component, a notification toast component, which basically is the notification batch which comes in app, and again a barrel export component or file. Now the final step is understanding the entry points and few other configurations. So this will be our main file, where we do provider hierarchy and dependency injection into this main file. We have fuel wallet connector setup over here. Then we have context network fetching wrapper, and we also have a white environment variable file which fetches the environment variables from the global environment variable file and sets up those environment variables for our white app globally. So this is how the code base of our app looks like. And again, the entire repository of this app will be linked in the description below. You just have to do npm install, set up the environment variables, and then just do npm run dev. And once it's running, the app will be live on localhost 5173. So let's just copy this and open it in our browser. So as you can see, this is loading from the app.tsx file, which we had seen earlier. And let's see what our wallet's network is right now. It's fuel Sepolia. So if we connect it, it won't throw any error because our wallet is on Sepolia. And for testnet, it's set up to do mock transactions. So you can also see that the price chart components is over here. And since no balance is found, we also have suggestion to get few tokens from fuel testnet. And in between this, if we switch to fuel mainnet, it should throw an error. So let's just disconnect, connect to mainnet because we want to see how we can trade. So let's just go to the Degen trader. Now you can see that we have this drop down for 3 tokens. We have the price component, we have the volume component, we have the 24 hours high component, we have the RSI, we have the price chart, we have the chat box interface over here, we have the wallet balance, we have the agent performance, all of these coming from these components over here and being displayed by this. So since the app is just running for a few minutes now, you will not see a lot of price action over here, but you can still see that the graph has moved a little bit. And if the app will run for a long time, you will see graph to move a little bit. And you can see that the RSI was changed in real time. Now let's move to fuel because we want to buy fuel. And since this is a Degen trader, it might have some views on fuel. So let's ask, what do you think about the fuel token? So as you can see, it says the fuel token is a classic Degen play since it's at a low price right now. So it will suggest us that we should buy it, and it's telling us to buy 100,000 fuel. It's suggesting us to buy 100,000 fuel since this is the Degen trader. But let's just say let's just buy 1 fuel token for now, and it will give us a trade where we can buy 1 fuel token. So if we execute this modal will get opened where it comes from this file, trade confirm modal, and in that you can see the action is buy, token is fuel, amount is 1 fuel, current price is this, and here's our agent's reasoning. And if we confirm trade, it should open our fuel wallet to confirm the trade. You can see the fuel wallet is open now. You can confirm that we are spending ETH and getting fuel via Mira. So if we submit it, you can see the notification toast has come up over here, and these are the transaction details. If we click on this, it will take us to Fuel Explorer. You can see that the balance of fuel token has changed from 6 to 7, and all of this we have coded in the trading dashboard except transaction hash, which we get from usetrading.ts file. You can see that we are importing usetrading from hooks. And if we go to some other kind of bot, let's say whale watcher, you can see that we have a whale activity section over here where it gives us the whale activity. This is just a mock data for now, but similarly you can implement something where it gives us actual whale activity. And similarly diamond hands. So for diamond hands, if you tell it that let's sell, it will tell us that you should not. Should I sell my fuel tokens? Yeah, so you can see that it's telling us to hold those tokens. So this is how you can create the AI trading platform on the Fuel network. Hope you learned something from this video and hope you found this application a little bit interesting. This will be linked in the description below. You can play with it, you can modify it to create your own application, use components or few parts from this application or code base, however you wish to use it. It's completely up to you. But make sure that you make your trades cautiously and use the application cautiously. The application is just for the purpose of demo to show how you can create something like this. Please do not use the application to make real trades on mainnet. It's just for demo purposes, and you should not take this as an actual AI helper. Thank you everyone. See you in the next one. Bye bye.